pull out your plan book. Yeah, we're map testing. I'm not quite sure how that's gonna affect our schedule.
Wait, does high school have math tests or no?
It doesn't matter. Map is individual to your performance. It doesn't actually relate even to what class you're in. Math is just particular to you as a person.
Why?
So literally what it's designed to do is show you your growth across year to year, which doesn't matter what class you take, right? Your growth doesn't actually matter on what class you're in. You could grow way more this year versus last year, regardless of who your teacher is or what class you're in. That's what math is used for. So yeah, our schedule is going to be tweaked in the next couple of days. This is my plan. That doesn't mean it's all going to happen. Please make sure you're looking at HSM2. This is my plan. Again, I am recording in case anybody misses a class or you loved it so much you want to go back and watch it again. Or the more likely thing, something happens that was funny and then it is preserved on YouTube for all time. Or as we get into actual complex ideas and things don't quite make sense in the 43 minutes I have to teach you guys. So, as you can see here, it looks like we're going to wrap up chapter 1 this week if we make the goal. I feel like I got a tiny victory over the weekend. You want to see why? Watch what I can do now.
Can you do a backflip?
No.
Oh, can you do that one thing Mr. Hall could do where he did the coins on his elbow?
Oh, I can do that too, but can you guys not do that?
I tried it.
I've never tried.
I tried it and
It's
half
gravity.
the coins
It's all
scattered
about
all
gravity.
over the place.
I feel like you'd have to practice a couple times to be able to do it, not to do it.
You just gotta work with gravity.
It's just like do that, right? Like you
Here's what I accomplished over the weekend. It works on the smartboard thing, so it can actually get recorded in the video. So it's not just like in this little picture-in-picture. This, hopefully, I think, is actually showing up on my screen, so it is actually getting recorded. Sweet! So today.
Can we go back to the homework thing? I know.
Uh-oh.
Sorry.
You know what I can do? I can just from right up here click back to the homework thing.
Whoa.
I gotta remember how a smartboard works now that I finally got it hooked up. So what was happening, for you techie people that care, is it was trying to communicate the touch back to monitor 1, and that screen was cloning monitor 2. So it was picking up touch from monitor 2, but applying it to monitor 1. And I figured this out when things started being goofy, because I was like, wait, I was over there. How did something get changed on this screen? And I realized it wasn't a ghost, right?
What's on Friday?
Closure.
Oh, okay.
Oh, that's so like you touched that screen in that position on that screen got touched on.
Like one of my applications opened up. So imagine if all of this was not up and one of these files just randomly opened. That's what let me know wait a minute, something's happening. All right, so I got a question. Do aliens exist?
Does it matter?
Why? I mean, that's not my question of does it matter if aliens.
Not enough evidence.
Sure, why not?
What do you mean not enough evidence?
I mean, we haven't seen any concrete proof either way.
Proof. What do you mean by proof?
I like proof. Those are like the math thing.
So proof could be the t-shirt design. I think you designed it, didn't you? That they sent over to say, here's a proof, check it, make sure it's good. That's not what we're talking about here, right? Proof. Evidence. So if we think about things we know versus things we don't know, it comes down to proof, right? So I kind of have to believe that aliens exist because the probability that they don't is so small, right? The fact that we exist, the probability that other intelligent life forms exist is just, it's very, very strong.
Although, granted, they may never find us, and we may
Right.
never find them.
Because also the probability of contact between the vast amount of space we're talking about here, yeah. Anyone watching What If on D+?
Oh, yeah.
So I'm getting into What If and love if you have Disney Plus and you haven't looked at What If, the first episode reimagines Captain America but puts Peggy
yeah.
as Captain America. So sweet rewrite of make the female the first superhero, and then episode 2 puts T'Challa as Star-Lord. So it's another reimagining of let's put the African American character in the big power role, because back in the 60s and 70s we weren't doing that. We weren't putting women in the star role. We weren't putting African Americans in the star role. So it's a sweet reimagining that I like what they're doing with it. But all right, so proof. So what if, this is why I brought up what if we weren't allowed to use any mathematical things we know if we hadn't proved them, right? So if we go way back in time to the days of Pythagoras or whatever, when you think famous mathematician and old, dead, long time ago. By the way, I'll show this to you guys later. The Pythagoreans are going to come up a lot this year, and I might show it to you now since I'm going to make you curious.
Oh, is that a tiny disc golf structure?
Yes, it is, because I'm a nerd. But so Pythagoras did a lot of things. And maybe while you guys talk about this, I'll go get some water. But one of the things Pythagoras did was truth was very important to him. Truth and proof. Right? And because of that, anytime the Pythagoreans got together and they were all drinking, right, they had wine or whatever else, Pythagoreans was his club. Pythagoras invented this cup called the cheater's chalice. And the purpose of it was that if anyone tried to be a lush and overdrink and take more than they should, they'd get none. So all of this, none of that really matters what we're doing today. But proof. We know these things and we relate back the Pythagorean theorem, right? And we just claim that it's true because we know it. But how do we know these things? Angle relationships, right?
That's old dead guy proof.
Right, but let's not just go with old dead guys because we're alive.
The book told me it's true.
Okay, book told me it's true.
CPM
But aren't there lots of things written down, and especially on the internet now, that aren't true?
Fair point. Yeah.
So we should always kind of have a discerning eye on, and always check it for ourselves, right? If we're going to use these things and we're going to claim them to be theorems, what's the difference between a theorem and a conjecture?
A theorem has been proved.
Theorem's been proven. So if we're going to claim that they are theorems, let's prove these things. So, okay, certain things we don't have to prove because just we created our system to do certain things. How many degrees are in a right angle?
90.
Because we did that, right? We could have just as easily made it 100, make another base 100 system. I don't know exactly why we didn't. Well, okay, we can't talk about why we did because 365 days in the year and rotation and all those things. But so if we know complementary, right? We don't need to write down this vocab. So some old dead dudes claimed that complementary angles are the two that add up to 90. So now we are able to say, with pretty good certainty, gotta get back used to this, that if CBD is 76,
Then that other one would be 14.
14, right? So we know certain things, we can figure out certain things based off what we know being proven. This is also why I like the smartboard software way better, because then my ink scrolls with it. So for as much as I like the fancy pants this thing, I actually probably use smartboard most of the time this year. Okay, and then we said a straight line makes 180 degrees, and we called that relationship supplementary. And then two intersecting lines,
Vertical angles.
which are
Equal.
Congruent.
why?
Because the straight lines have to add up to 180. And
Okay. So let's say
We
somebody,
did a proof on this last
let's
year.
say an alien comes into our classroom right now.
Whoa, that'd be
Star-Lord, whoever, the dude who's blue with the thing that he whistles, I want to meet him.
Yondu.
Yes. Yeah, he's so funny. I just think they wrote his character in this kind of angry evil, but really funny. So let's say Yondu comes down here, and Yondu doesn't strike me as the brightest bulb in the box. And Yondu is like, watching our math lesson is like, no, but I don't understand this vertical angles thing. Why? Right? And if you can imagine Yondu pushing on the why thing, he would probably make you defend yourself. So I want you guys, in the most efficient, short, right? Don't meander away. But how could we say because of this, because of this, because of this, vertical angles are equal? There you go, Yondu.
Ooh, I got it.
Well, talk with each other. So, you guys can come up if you want.
Alright, I'm gonna do it.
Right up here.
I'm gonna do it, wow.
Okay. Do you have an idea?
Oh, eraser doesn't do what the normal, you have to click eraser. But aside from that, everything's awesome.
Okay, so,
Everything's cool when you're part
these
of a
angles,
team.
this one is supplementary to this one. So, if we say this
Want
one.
to make your life easy? Use lowercase letters. Name your angles.
Okay.
Because this one and this one is going to get confusing very fast.
Yeah,
Okay,
this one's
so
my favorite.
we have a straight line here because it goes between 2 points.
Oh.
Oh, no.
And so it makes angle A and angle B because it's split by another line. So angle A and angle B are supplementary.
Gentle, Jane.
Right?
We also have angle C on this line, which is also supplementary to angle B.
Why?
So if angle A and angle C are both supplementary to angle B, then they have to be equal.
Did we follow?
Yeah. Because, hold on.
Yeah.
If, remember we said we're going to use a lot of if-then this year?
Oh, yeah.
If angle A plus angle B, crap, this is the only issue with when I forget things and I can't just as quickly, equals, what did we say? 180, and angle C plus
Oh,
angle
so then,
B
okay.
is equal to 180.
Why does your writing look so fancy?
Because
Then-
you're using a calligraphy pen, like you were as well, but he's also much used to it.
I've been,
10 years or something?
Yes, 10 years of
There
this.
we go.
This is my, I get to now say 10 years teaching, brush all the dirt off my shoulder. So if angle A plus angle B is 180, and angle C plus angle B is 180, then by what?
Substitution.
By substitution. And we can abbreviate substitution, just SUBS.
Okay.
Woohoo.
Well, you kind of skipped this stuff, I feel.
Ooh, what did I skip?
I feel like it would have been angle A plus angle B equals angle C plus angle B, and then you subtract from both sides to angle B.
So to make this claim that we can substitute this in, we have to first relate the fact that they are both equal to each other. We've already said it, but we haven't said it explicitly. We've said it individually, they both equal 180, but what we actually want to say here is, okay, so A plus B is the same as C plus B, and now so this is where, and always do that, because I did that on purpose. Always, if you think we've forgotten something, if you say, well, wait, before we can get to that, we have to say one more thing, always fill in that gap.
Oh, this is like those proof things we did
Yeah,
last.
this is
This.
Whoa.
So
it's
now,
the same thing.
you guys have maybe been used to flowchart proofs, maybe. I don't know, flowchart
Oh, yeah,
proofs.
we
We did like,
I like two
Hey,
colors.
We also use the 2 columns.
So, grab a
Yeah,
piece of
that's
paper,
enough.
if you don't have one out yet, we're gonna write this out, 2-column proof,
Are
make
we
it kind of
supposed
fancy.
to turn it on homework come Friday?
I'm not worried about you guys yet, because I trust you. I'm trying to get my 7th graders in a habit.
okay. Don't say that, Jake.
Why, it's funny.
Do we?
It's only funny when you're talking about that.
I'm trying to double check, but I just got way too far ahead.
It's not funny when you
Yep. So, here's our actual problem. So if you want to write down that this is from 1-70.
What, lesson?
121, I think, or what? I had it up there when you guys came in. 131? I think
That sounds right.
Yeah.
Yeah, 131.
You were doing the
So in a 2-column proof, because it sounds like you guys have already been introduced to those, what are our 2 columns?
statement and reason.
Statement and reason.
Thank you, because I forgot that.
That is why we're doing this.
I'm gonna recycle the thingy from yesterday with the different lines of yes.
Is that laminated? Oh, no, okay.
So,
Why would it be laminated?
Because the thing was laminated, I thought you were recycling.
wait. When we start our proof,
We have to do a given. We have to write all the information that's given to us.
okay. Now what is given?
Wait, for that equation?
You have 2 intersecting lines.
Okay.
A plus B equals 180 and A plus B.
A and B are supplementary, A and C are supplementary.
So essentially this, right?
Yeah.
Sorry about my line crossing
And
through.
then-
So that we just kind of know because, so our statement of A, but what? Okay, so A plus B, I'm going to quit using the angle symbol because we know that we're talking about angle. But what?
It's given.
But is there any, like, I get that it's given, but is there anything else that we could claim why this is true?
I forget what's called the theorem or whatever, but the 2 angles that are on a straight line out to 180.
Yeah.
Linear pair.
Linear pair!
Yeah.
Linear pair theorem.
So proud of myself.
I was gonna say definition of supplementary.
But that is literally what we're doing right now, so I'm so glad you said
That's
that.
the next one.
You can't use what you're trying to prove. So if you've been asked prove aliens exist, you can't say what aliens exist. Like, that doesn't work, right? So if you get asked prove supplementary angles, you can't say, well, supplementary angles. What we're allowed to say is a line makes 180 degrees, right? Which that's what linear pair means. So then also, is it B plus C?
C plus A plus B.
C plus B.
A plus C, with how their diagram is.
Oh,
C
I was
plus.
right.
And since that's the same, we can ditto mark.
Oh.
You can totally ditto mark in your proofs.
I've never.
I just put them both in the same, like, statement.
Woo, yep, or you can also just put linear pair kind of between the 2 of them.
That's what we did last year.
You can also do one of these things
Ah.
to like group them.
Bracket.
Yeah, the fancy pants bracket.
I can never.
So now we
I
said
can never draw that without it looking really stupid.
Right?
A plus B equals A plus C. Why,
Oh, yeah.
why are we allowed to do that?
What's it called?
Actually, I said it earlier, right?
Oh, I did.
Substitution.
No.
Yeah, it is substitution.
It is substitution.
Oh, yeah.
Because we're saying this value equals this value.
Oh, right,
So
okay.
instead of saying 180, I can say A plus B. So this is substitution.
Okay.
Oh.
And then, so wait, how can I say that B equals C?
What's it called?
The thing where you can subtract.
Something property of subtraction.
Subtraction problem.
Of,
Both sides getting rid of this.
did we start equal?
Associative property of subtraction.
Associative. Associative is what you associate. Associative
It
is.
reflects.
Oh, I didn't teach you guys.
What?
You didn't teach.
I taught you.
Oh.
The associative property, do you remember what I used to help you guys remember the associative property and what it relates to?
No.
I'm surprised you of all people. The associative property deals with parentheses. The first 3 letters of associative property, do not say it out loud. This looks like a butt.
Oh, no,
Looks
you
like butt
didn't-
cheeks.
you didn't
Right?
say-
Parentheses look like butt
I
cheeks.
have not been here that
What's the property? Like, what is the property?
Associative property is when you put parentheses to associate numbers with each other. When we insert or move around parentheses with what is associated. We'll deal with that, but that's not this, right? There's no parentheses involved here.
Oh,
What did we do?
So we didn't subtract A, so we
And we stayed equal because we did it on both sides. Subtraction property of equality. There's multiplicative, there's division, there's addition, there's subtraction. Anytime we're doing anything on both sides, so this is just like subtractive property of equality. Oh, I'm so used to having to come back over here. So our next one. Go ahead and dive into this on your own. I'm going to go get some water to show you guys the cheater's chalice.
Ooh, cheating. I like cheating.
who does?
No, but seriously.
And then when you get away with it, it's
When you have multiple parentheses.
In choir this morning, there was a kid that just was like doing another kid's homework.
oh, I did that in orchestra
Why?
Why?
because she needed help, so I just wanted to help
So
her.
you just did that?
I didn't do it. I helped her. I was a
So wait, how does the cheater's chalice work? Is there like a hole in the center column?
It looks like there's a hole,
last
like,
year.
around
I
that
used
side.
the sequence of weird transfer.
How does it get rid of all of them?
So
No, I used
when they overfill, the chalice will just explode, right? No.
Real?
No. So
Oh,
you're at dinner. People are pouring around the wine or whatever, and you're supposed to take, a pour. Nobody's watching. I'll just pour a little extra, and nobody will know. So a little extra,
That's cool!
And it all falls out?
and all of your
That-
How
wine.
did you know exactly how much to put in?
Wine inside of this. So this is from Greece. My sister-in-law actually bought this for me when she went to Greece, brought it back for me. So how this works, we'll investigate later in the year. The only amount of water that stayed in there was the water that was trapped inside of it. And that's what I just poured out. But yeah, so you can fill up to a certain point, and nothing happens. You could drink out of this, totally fine.
That's so.
You surpass that point,
I feel bad for the person.
Does it like overweight the bottom and then like flip it back up like a trapdoor or
it's
something?
physics.
Huh?
It's actually really simple. The design of this,
I don't get it. I
I still think it's.
Seems cool.
don't understand. It is cool, but I don't get it.
Looks like a mushroom.
so really this is not working because this needs to be drawn differently.
No, it looks like a,
So there are like little holes down here. And you can put a certain amount of water on here totally fine. But as soon as you get above the line, the weight of the water, and actually you might be able to hypothesize what's happening. There's a pillar inside of here. So as the water level increases, it's fine. It's not going to go anywhere because it can't get over the pillar. But this has a hole in it. So as soon as you pour enough in that it gets over that hole, you guys know what a siphon is? As soon as
It's like a
suction
vacuum.
starts, it will keep sucking until something breaks the like air, water, gas, like whatever siphoning. As long as it continues,
Wait.
it will keep going. So as soon as the water gets high enough to go down the hole in the center stem, it sucks it all out.
Wait, does it like go up though?
Yeah, so these holes, water fills. So water can go up as long as it's still filling. So water won't go up on its own, but if you dump water like into an object that it can go over and then climb up, if this level of water increases, this level of water will increase.
Yeah, no, I get that, but I mean like once it goes into the hole, wouldn't like just the stuff inside there and maybe like enough to go to the top of it?
Create
really go up?
suction. Nope, create suction. That's how water can then climb. Suction's pretty powerful.
Wow.
Here, one more time. So that's safe, right? And I could, like, if I can get the water out of the edge, it's not gonna, so if you can imagine there's a hole inside the middle of this on an inside pillar,
Yeah.
right? The water can't get to that hole when I tip it because it's all coming this way, right? So when it's flat and I go over that point, now it's sucking. It's pulling it all up through and straight down. And the
Wow.
weight of the water coming out of the bottom is what sucks in the water from the top.
I wonder how you felt when you
Oh.
built it and then people would try it. I wonder how you felt. Like,
Yeah, and then you'd be like a mess, right? You'd look all over.
Yeah,
you.
You probably feel like half.
Hot, nerd.
You'd be like, sucker.
All right,
Ancient.
back to here. No, the one before.
Not bad.
So Mira said, I remember last year that I can use a sequence of rigid transformations, that angles are congruent. I drew intersecting lines on my paper. If I copy on a trace paper, I can transform. So here's my actual question to you in the first couple chapters as we go through, like, some things review, some things aren't. Would you like me to get out tracing paper and us practice this, or do we just want to skip on forward saying that we understand that when we transform rigid shapes, they stay rigid?
Unless you dilate.
Like if
Unless you dilate. But when we just when we just translate a rigid shape, it stays the same size,
Oh,
right?
just translating, like no rotation or reflection?
Right, so just,
Rigid transformations.
rigid. Rigid stays the same size. So I have tracing paper. You can have tracing paper if you want, but I don't think this activity is really worth our time because it is honestly just you draw over top of a shape and take it to another shape and look at the angles are the same. So let's do some actual math.
Woo, man.
Try these on your own first because I don't want you guys to shout out answers. Using our angle pair relationships that we know, solve for x in each of these images.
Like both of them or the one that they asked?
Well, both x's will be the same.
Well, yeah.
Solve for X.
So then we'll find the angle measure after we have x. But we're going to have to start by finding x.
I just put down it's 3x.
Huh?
Duh.
Wait, what problem number is this?
72.
72.
What relationship are we going to use in A?
Linear pair.
Yeah, they're supplementary. What about in B?
Just like regular. Wait. Oh, congruent.
Ah, there we go. They are congruent. Just wanted to make sure that you guys saw that.
Notifications.
For A, what did we get for X?
54 or 18.
Ooh, 18, then making MNP 54.
Oh wait, yeah, I forgot to calculate that. Wait,
Yeah, finding X is the more important thing here, then finding the angle is not too hard.
Did you get 50?
Hmm?
Did you not say 15?
No, you said
Oh, yeah, okay.
Because 10X would be equal to 180.
Yeah, I got 18. I was just confused because I heard 15.
what is the biggest high school math class?
I mean, oh, that I've had?
Yeah.
Like, it's not big for a class.
Should get X is 7 for part B?
I
Wait.
got
Yeah.
I love you.
Oh, yeah.
You
Okay.
good now?
Yeah, okay, that makes sense. Very nice.
Part C, X would be 29.
Can I go to the bathroom?
Absolute logic, can you? The cheesy teacher thing where we make you use the correct grammar.
Wait, I thought this was math class,
No, he said
not
that's
grammar class.
Grammar doesn't have its own class.
Why doesn't grammar have its own class? Like, I would skip it. Like, why doesn't it have its own class?
Used to, I believe, back in the good old days.
Good, because there's so many things.
So then here, 2x,
Plus 28 equals 180.
so 2x equals,
X equals 7. Yeah.
so, one thing we just want to make sure, and this is why I was complaining to Mr. Hall the other day, that I really wish we had a pool table.
Ooh,
Cool.
fun.
Like, I do like swimming.
Billiards, I should say, billiards
that,
table.
That game.
So, light reflects off of the object at the same angle that it came to interact with the object. So, what I'm saying here is when we look at reflection angles, those would be
Wait.
congruent to each
But
other.
what if it's like a wanky mirror?
Well, then, yeah, then that's not going to happen the same as it.
Uh,
Flat object, reflecting off a flat object, normal flat object. And this is another one where I think you guys actually are smarter than the normal.
Oh, thank you.
Yeah, smarter than
scholars?
the normal math. No, then what I'm trying to say here is a person who would normally take math 2 would normally be a sophomore. You guys are better than that because you're younger. You put on the gas pedal.
Agile brain.
Sure, agile brain. I'm trying to find my theorem graphic organizer. Because we're going to start to use our theorem graphic organizer to keep track of these things. So if you would like, I gave mine away to one of you guys. You can add our supplementary angles to your theorem graphic organizer.
What's
Have
that
one of
theorem
those?
graphic?
Here.
What?
It looked like,
Oh,
Wait, what do you need?
it's got a bunch of rectangles on it.
the rectangle
This.
paper. Okay.
Wait, I have one.
Wait, that's not what I thought you were talking about.
Did I not give you guys one of these?
No, I don't think so.
Wait, do we need this paper still or no? Or-
What is this paper?
That's why I was
Oh,
using
I
write
found
down the stuff.
something. Is this it? Oh wait, is this it?
Yep.
Okay, cool.
It's probably, did you give it to us like in one of those big
It's like
bunches
the
of
last
stuff?
page, probably.
The
Like
last?
the, let me see, okay, I found it. Good job.
Here, I got the key.
Yeah,
I don't have the actual organ.
yeah.
You
Maybe it's
should.
on this page, right in front of it. That's another key. Wait, I have one.
What?
I have one empty theorem graphic organizer.
There you go.
I don't.
So,
Like,
I thought you said you just found it.
No, I didn't.
wait, is it like in the key?
There you go. I need a print for you guys.
Wait, am I not supposed to have this key?
I mean, I have the key.
I gave you guys the key on purpose.
Oh, okay.
Which one do you have? This one involving vertical
Yeah,
angles?
I have those.
Yeah.
And then like two
okay.
below it, there's an empty.
So down here, if you wanted to, and we'll print these a lot this year because we talked in a lot of theorems this year.
That's good.
So the other thing to go with a theorem is its converse.
Oh, yeah.
So if our theorem here is that our vertical we have up here, don't we? We've got vertical. So if we wanted to add a theorem, we could do it down there. But our converse So if our theorem is that vertical angles are congruent to each other, what's the opposite of that?
Well, for that example, C is congruent to B would be the opposite.
The opposite?
No.
That's the same, isn't it? You flipped it around, but it's the same statement. Mathematically, it's the same.
Yeah. The other two things, like A is congruent to whatever that fourth.
Do you guys remember the difference between converse, inverse, and contrapositive?
What's contra?
I think
I got my
that's
doors locked. I don't know who locked my door. I think they came around before the lockdown and locked my door. But I don't like my door being locked. Jacob, do you remember the difference between converse, inverse, and contrapositive?
What?
So, maybe before we dive into this school year, that's something we should make sure that we're aware of.
Opposite of theorem, right?
Yeah.
So like the,
Wait, isn't inverse where one of them is like saying the opposite? Wait, no, that's.
Hypothesize with each other. What do you guys think?
I know what converse means, but it's hard to describe.
Okay, what is
Converse is just like flipping it over, like the opposite. I don't know.
like if
The theorem is the opposite.
Yeah.
well, we could look at this example of a converse for the Pythagorean theorem.
If a triangle is the right triangle.
Yeah.
Okay.
Yeah, so A squared plus B squared.
So it's
equals-
like
All right.
flipping the if and
It's
then.
like yeah.
And then for inverse, the if is no.
The if is opposite and the
The
then
if
is
is
opposite.
negative.
Write down statement, converse, inverse, contrapositive.
Where?
Wherever. I'm going to make a new.
Oh.
This is just one of those things like we're gonna need to know this year. So like now that I realize that you guys don't know it, we're just gonna write it down, and because we have time.
Converse.
So statement, converse, inverse, contrapositive. Our statement if P, then Q. If angles are vertical, then they are congruent. The converse. If Q,
Wait, but that's not true.
then P. Now notice what it says after converse. What's it say in parentheses?
If proved.
If proved. So, if angles are congruent, does that mean they're vertical?
Not necessarily.
Not necessarily. So is the converse always true here? No, not always true. The best definitions, all of these are true. So vertical angles, just say if angles are vertical, they're congruent. We could make that better. That's just, it is true, but we can make that better. Inverse.
If negative x, then negative
If
y, or
not
negative
P,
then
then Q. I think. I don't know.
If negative P, then negative Q.
Close, but we do say not here. So because we're talking about events, so now the inverse is if not vertical, then not congruent. Is that always true? If my angles are not vertical, they are not congruent.
No, not always true.
No, that's definitely not always true. Take a stab for the contrapositive.
If not Q, then not P.
Yep. And that's it for today, guys. I wanted to double check those before we wrote them down because it's been a minute. Yep, if not Q, then not P.
Converse and contrapositive are similar, and the statement in the inverse means the not, and then the contrapositive is the like converse of the inverse.
Yeah, or the inverse of converse.
Oh yeah.
All right, friends.
Can you play a song when we're leaving?
Wait, so would the inverse of the
Can you
inverse
play
just be a
Super Free,
statement?
please?
Like
The what who?
Super Free. It's an 80s classic.
What were you asking about?
Oh, me?
Yeah.
If it, would the inverse of an inverse be a statement?
Mm,
Or is that not how words work?
yeah. Because it is the reciprocal of a reciprocal what you started with. Yeah. Essentially.